Hey guys, welcome back. So we're still talking about our discussions of exponents and how we can expand these exponents fully and then simplify them back down. So now we're going to be looking at exponents that are in fractions. Okay, so quotients is the word fractions. Quotient is the answer to a division problem. So when you see the word quotient, you can think fraction or division. And that's what's happening here in these examples. So you should have two of these, one with parentheses, one without. We're going to look at this one without parentheses first, and then we're going to take a look at the assignment that you're going to do afterwards, that this will need to be turned in for a grade. Just like the other white one that I just did a video over before with products. So first let's look here at quotients with exponents. And let me get a pen. So, and it looks kind of minty green in the video, but this is actually bright neon green. So I don't think you have the wrong one if it doesn't look like it's the same color, because it is kind of minty in the video, but it's a bright green, neon green. Okay, so here's the idea. Just like before, when we were taking products, we were expanding them all the way and simplifying them back down. We're still going to do that, but now we have a fraction. So we have a numerator and a denominator, top and a bottom. So we're going to expand the numerator all the way and expand the denominator, and then hopefully we're going to see some things that are going to divide out to 1. They're going to divide out and equal 1, and we're going to be able to cancel them. So look at this example here. We have 2 cubed over 2 squared. So that was taken. And 2 cubed is 2 times 2 times 2. 2 squared is 2 times 2. So this was written out as repeated multiplication. And then over here we can simplify it, because we know that 1, 2 divided by another 2 in the denominator, it's going to equal 1. 2 divided by 2 equals 1. So we can cancel those pieces. Well, then I have another 2 that I can divide by 2 in the denominator. And I see that I'm left with just 1, 2, and it's in the numerator, so it has to stay there, and it becomes 2 to the first power. 2 to the 1, or just 2, right? Because any number that doesn't have a power written on it, it is 1. So I could write this over 1 to show you that, yeah, that 2 is still in the numerator, still on the top of that fraction. It needs to stay there. Okay, so this one's very similar. So I want to move down to this one that has X's on it. I'm going to do a few of them, and then you can fill in the rest of the table on your own. So notice here we have x to the 10th divided by x to the 4th. So I'm going to have a big long fraction, and I've got x multiplied by itself 10 times. So let me write out all these x's. Did I get them all? I like to go back and count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now if you run a room, it's real important that you just move over into this column. You do not want to write the numerator of your fraction and then go on to the next line. You need your numerator all in one big line. So just take up as much space as you need to and write your answer over here to the side if you have to. So now I'm going to write my denominator. X times X times X times X. I have X as a base multiplied by itself 4 times. So now I'm going to go through and I'm going to say, okay, well, I can cancel some things out, because I can see if I have 1x, I'm going to get a different color. If I have 1x divided by itself in the denominator, that's just going to be 1. And I don't need to write that 1, because 1 times anything is still that number. 1 times any number just equals that number. So then I can do another one. I have this x I can divide with this x, and that would become 1. I have another x I can divide with that x, would be 1. And I have one more that I can divide with that last one. So I've divided all those x's out, and those have all become 1s. 1 times 1 times 1 times 1, but I don't need to write them, right? Because multiplying by 1 is what we call the identity. It doesn't change the value of the number. So I'm going to say, well, I'm left with any x's in the denominator? Nope. So all that's down there now is a 1, which remember, I don't have to write something over 1. So I'm just left with x to the power of 1, 2, 3, 4, 5, 6. X to the 6th power, because I'm left with x in the numerator multiplied times itself 6 times. So x is a base with a power of 6. So this is the idea. These are pretty simple. I want to look at this one because I've had some questions about that one. So the question is, we can clearly see in the numerator, I think, what we need to have. We have 5 with the power of 2, so that's 5 times 5, right? And then we have times y 10 times. So we have to write 10 y's. 2, 3, 7, 8, 9, 10. Now notice how I went over into this column. I'm not going to make you rewrite it and do your canceling in this column. You can just cancel here after you write it. I'm fine with that. So my main question has been, okay, we have 5 times y to the 8th, or 5y to the 8th. And the main question I've heard is, how many times do I write the 5? Do I write 5y times 5y times 5y times... So we need to look and say, well, is that really what's happening? Remember, 5 is multiplied times y, so I could really put a dot there. There's no parentheses around the 5y raised to the 8th. It's 5 times y to the 8th. So the power on that 5 is 1. So we only write 1 5. And then we write 8 y's. Okay, so did I count mine in the numerator? I don't know. Let me count them and go back. So I had 10 in the numerator. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Good. And I should have 8 in the denominator. 1, 2, 3, 4, 5, 6, 7, 8. Okay, I've got all of them. So I'm going to go back now and I'm going to cancel. Now remember, you can only cancel one element in the numerator with 1 in the denominator, and it has to be the exact same base. So I can't cancel a 5 with a y because I don't know what number y represents. I don't know that it is 5. I know I can cancel 5 divided by 5. That will be 1. I know that y divided by y is going to be 1 because even though it's y and I don't know what the number is, it's the same number in the numerator and the denominator. So I can cancel 1 with 1. 1 with 1. And this is what I urge you. Don't go through and start canceling multiples. Do them one at a time, because what you'll do is you'll end up canceling more than you should, and you'll have a wrong answer. Okay, so now I'm going to look and say, well, what's left? I have 1 5, and its power is going to be what? 1 times y, and I don't have any y's in the denominator, but I do have some in the numerator. I have 2. That's my answer. So notice, if we didn't put the 1 there, it would look like 5 times y squared. But look back at our answer. That didn't mean 5y times 5y, because we only had 1 5. So this is why when you see a number like this, an answer, know that 5 has its own power, and it is 1. Okay, I want to do the next one, this one right here, because I received questions on this one too. The expanding is pretty easy, but it's when we go to write our answer, we have to make sure we're doing something correctly. So I'm going to do this big, long fraction again. And I know I have 7 a's. So I'm going to expand that out. 6, 7 times 2 b's. In my denominator, I have 2 a's and 6 b's. Okay, 1, 2, 3, 4, 5, 6. 1, 2. 1, 2, 3, 4, 5, 6, 7. I got to count them, like I say. Okay, so now I'm going to start canceling, and this is going to be great because a ton of stuff's going to cancel out. I like this. This makes me so happy. So I have a divided by a, and another a divided by an a, and then I have 1b here, and a b here. And it doesn't matter. I could cancel this b with this b. It doesn't matter which ones you cancel. I'm just going to do 1 and 1. And I think that's it. I think that's all I can cancel. So I'm looking and I say, okay, I know I have a to what power? 1, 2, 3, 4, 5 to the 5th power. And then I look and I say, well, I have some b's. Do I have any b's left in my numerator, though? I canceled them all out. I do have some b's in the denominator, though. And I look and I have 1, 2, 3, 4. But notice they're in the denominator, so they need to stay there. So that's going to be over b to the 4th. So I've seen a lot of students write this as a to the 5th and put b to the 4th next to it, but b's are not in the numerator, they're in the denominator, so they need to stay there. So you are going to expand and simplify, but you're not always going to simplify back down and not have a fraction. Sometimes your answer is going to be a fraction, and that's okay. Okay, so I want to move on now quickly and look at this one right here. So notice sometimes we have fractions in parentheses and we need to write them out. however many times it's telling us to. So this was 2/3 to the 4th. So you wrote it out this many times. And notice, remember, fraction multiplication means you multiply all your numerators and all your denominators. So this is really 2 times 2 times 2 times 2, which becomes 2 to the 4th, over 3 times 3 times 3 times 3, which is 3 to the 4th. So, I want to skip down. I want to look at this one right here. So, I need to write out my stuff 3 times. I don't care what that stuff is. I just need to write it out. 2x over 9 times 2x over 9 times 2x over 9. Okay, I've written it out 3 times. Now I'm going to do another column because I'm going to show you what this equals. It equals 2x times 2x times 2x. But I want to write it like this. 2 times 2 times 2 times x times x times x. Right? We can do that. That's legal. I can rearrange the multiplication. And remember, this 2 is multiplied times this x because it's just sitting in there. So I really could put multiplication symbols in between. It wouldn't change it. 2 is multiplied times x. Because what I want you to see is that we really have 2 to the power of what? 3 times x to the power of 3 over 9 to the power of 3. This is correct. What I have seen students write a lot is 2x to the 3 over 9 to the 3. They're writing this because they're going straight from this piece here. But what they really mean is 2x to the 3. And that's not what they're writing. So this is a correct way to write it because you're saying I have all of this stuff cubed and this is correct. But if you don't put the parentheses, it's not correct because you're not telling me that I have 3 2's. So, like I say, this is one of the ones I saw the most trouble with. So, number 7, you just need to write your stuff out. How many times? 7 times. So we could do that. This is not number 7. 1, 2, 3, 4. It's number 5. 3a squared over 12b times 3a squared over 12b times 3a squared over 12b. So we're going to keep going until we get it written 7 times. I think 1, 2, 3, 4, 5, 6. Yeah. I need one more. Okay, so now I'm going to look. I'm going to try and write my fraction here. And notice I've got how many 3's? 1, 2, 3, 4, 5, 6, 7. So I have 3 to the what power? 7th power. And then notice I could expand this further. Could I change this to say a times a? And that one to say a times a? And that one to a times a? So notice if I do that, how many a's do I have? 2, 4, 6, 8, 10, 12, 14. So this is really a to the 14th power. And then I have 12 to the 7th power. 1, 2, 3, 4, 5, 6, 7. And then I have my b's. b to the 7th power. Notice I can't cancel any a's and b's because it's not the same base. It's not the same number. So they won't divide to be 1. Okay, so this is almost simplified. We have 3 to the 7th over 12 to the 7th. So what I want to show you is that we can take this even a step further, though. It's going to be some huge number, but that's okay, because what this really is we can think about 12 as factors. Does it have something in common with 3? That's what I want you to think. So could we have taken each 12 and written it as 3 times 4? Is 3 times 4 12? Yeah, it is. So we could take each 12 and write it as 3 times 4. We could simplify this just a little bit. So if you think about that, if I no longer have 12, if I wrote it as 3 times 4, well, wouldn't these 3's cancel? All of these? Yeah, they would, because 3 divided by 3 is 1. So then I'm just left with what in the denominator? Well, that would leave me with 4's. And 4 to what power? 1, 2, 3, 4, 5, 6, 7. So really, and I'm going to write this answer down here. I'm going to move it down here. This could really simplify as a to the 14th over 4 to the 7th times b to the 7th. Now this 4 to the 7th is a huge number, so you can just leave it as 4 to the 7th. That's fine. But you can simplify these even further. I'm not as concerned with you simplifying them on this sheet because I want you to see what's happening as I am on the assignment, which the problems are not as large. So this one is a lot to write out, but like I say, it's not hard. You're just going to need to expand everything, and then you have some canceling that you can do on this one. Because notice you'll be able to write this piece as x times x times x after you write this out 4 times. Okay? So now looking at the practice that you're going to work on next. So I'm going to let's start off with this one because it's pretty simple. So we're going to expand our numerator, then expand the denominator, and then do some canceling. So this one in here I have a to the 6th. So that's a times a times a times a times a times a. 1, 2, 3, 4, 5, 6 over a times a. So now notice I can come through and I can cancel 1a with 1a. So I've canceled all my a's in the denominator. I'm just left with a's in the numerator to the 4th power. 1, 2, 3, 4. Okay, so pretty simple, pretty straightforward. Now, let's see, what else can we look at? Something that maybe looks difficult, but really it probably is not that difficult. So notice with this one, you have something to a power of 2. So you're going to need to write this stuff, whatever's in parentheses, 2 times. So that happens to be v cubed w4 over v w9 times v cubed w to the 4th times v w to the 9th. So we wrote it twice. So now we need to come in here and we need to simplify even further. How many v's should I write? I should write 1, 2, 3 times w, 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 all divided by v times 1, 2, 3, 4, 5, 6, 7, 8, 9. Now notice this is just one piece. All that is going to be multiplied times this piece as well. So now I'm going to write my second one. I'm going to have to go underneath the line here, but that's okay. Whoops, v times v times v times 1, 2, 3, 4 over v times w. Okay, I think I got all of them. So now I'm going to go in and I'm going to start canceling each piece. I'm going to cancel on this one first. I've got v divided by v. Then I have one w divided by another w. And you're going to do them one at a time. And the same thing with your second one that you wrote out. Okay, so now I did my canceling. So now I need to bring it all back together. I need to see what's in common. So with this one, I'm going to have v times v, and I'm going to end up, I'm not going to work this one for you, but I'm going to write this one down here. I'm going to continue down. So I have v times v over, how many w's in the denominator? 1, 2, 3, 4, 5. Times, the same thing here, v times v over 1, 2, 3, 4, 5. Now I'm going to bring it all back together. Remember, I can make this one long fraction because that's what we do. We multiply numerator times numerator and denominators times denominators. So I really have v to the 1, 2, 3, 4th power divided by w to the 1, 2, 3, 4, 5, 6, 7, 8, 9, 10th power. And there's your final answer right there. So if you need more room to work these, feel free to flip this over on the back and show your work there so that you don't have to go into your other problem space. But I didn't want to flip it over just for the sake of the camera. Or get an extra piece of scratch paper or something and you can work on that. So these problems like 2 and 5 and even 4, notice you don't have to write them twice to begin with. You're just going to start with this piece, expand fully, and then simplify. So hopefully they're not too difficult. This one had the most steps to it because we had to first write what was in our parentheses twice and then expand each one. So the rest, this one, now this piece here, notice you've got 24 times some stuff that's cubed. And notice the cubed applies to what's in parentheses. It does not apply to the 24. So you're going to have to write 24 times x squared y times x squared y times x squared times y over 6 times x to the 6th y squared. So with this one, now you need to expand even further. And let's start thinking about 24 and 6. Can we think, is 24, does it have any factors that involve 6? Well, it does, doesn't it? Because can't we write that as 6 times 4? And then we would have x times y times x times x times y times x times x times y divided by 6 times 6x's times y times y. So now we're ready to go in and we're ready to simplify. Look, I have a 6 divided by 6, so that will cancel. Another x, an x, and an x. And then I've got another x here, another x here. I think I'm going to cancel all my x's first. Look, every single one of my x's just canceled out. I have a y here I can cancel with that one, and a y here I can cancel with that one. So look, every single thing in the denominator has simplified out. It's divided out to 1. It's canceled. So I'm left with 4 times y, and that's it. Now, I could put this over 1 because there's still a 1 in the denominator, but I don't have to. So isn't that crazy how something this complicated can simplify down to just 4 times y? That's it. So those are some of the more difficult ones on the sheet. So hopefully the other ones will be easier to you. Like I said, this does need to be turned in. It is an assignment. Take a grade on it.